Howdy folks, this is for my college algebra class. I wanted to show you because it could be sort of confusing and maybe we didn't get to it in class or we didn't have enough time to really spend a lot of time on it. But what we're going to talk about here is how to solve a linear, linear and absolute value inequality. Yeah, that's right. We got a lot going on in here, don't we? Linear, absolute value inequality, okay? It sounds big, but it's really not that big of a deal. If you know how to solve a basic linear equation, you can solve a linear inequality, an absolute value linear inequality. So watch this. Let's say that we have, let's start with something simple. Let's start with 5x. Let's say the absolute value of 5x is less than 7, okay? So the idea here is that if we put a negative number in here for x, the negative number times a positive number will make it negative, but absolute values will make it automatically positive, right? Because the absolute value of -4 is equal to 4. The absolute value of positive numbers, the absolute value of 7 is also 7. Let's see here. So here's what we're going to do. The basic idea here is this. Absolute value equations and inequalities and that sort of thing, they basically can be rewritten as a not absolute value if you make them into two separate equations. Okay? So if you know how to solve an absolute value equation, for example, if you had the absolute value of 3x is equal to 12, okay? I don't know if you remember this. The way that you solve that is you set up two separate equations. You do the regular 3x is equal to 12, and then you do another one, 3x equals 12, but you make the other one negative. So you have 3x equals 12 and 3x equals negative 12. Then you divide by 3 on both sides, and you get x equals 4, and then you again divide by 3 on both sides, and you get x equals negative 4. So because it's two separate equations, you get two separate answers. So 4 and negative 4 will each make this correct. So if I plug 4 in here, 3 times 4 is 12. The absolute value of 12 is 12. Put in negative 4 times 3 is negative 12. Absolute value of negative 12 is 12, and that's why there are two answers. Okay? So with absolute value inequalities, you usually come up with two answers also because, again, you have two separate inequalities going on here. But here's the trick. Here's the rule. The first rule is this. You already know rule number one is, rule number one is change the sign of the other side, the other side, in this case the 7, change the sign of the other side for the second inequality that you set up. That's the first rule. And you already saw that in the example I just did. We set up two separate equations and we changed the sign on the other side. The other rule is this, however. Okay, so rule number 2 is this, is that when you set up the second inequality again, okay, you have to change the inequality sign also on the second inequality. There we go. So those are your two rules if you want to write them down, if you want to pause it, whatever you want to do, okay? But I'm going to erase it now. So look, so we got this, right? So we got the 5x, absolute value of 5x less than 7. The first one is always the same as what you see, only without the absolute value symbols. So the first one is going to be just 5x is less than 7. Okay, that's just your regular Does it bother anybody else? I know I mentioned this the other day. Bother anybody else that the absolute value symbol looks a lot like a 7? That really drives me crazy. They should have come up with something better than that, I think. Okay, here, let's make this 7. Put a little thing on that 7. All right, so now, for this other one, it's going to be 5x again. It's going to look just like this one, only we're going to change this, and we're going to change this sign and change this sign. So now it's greater than, and instead of 7, it's negative 7. Okay, so now we got 5x is less than 7, and we got 5x is greater than negative 7. And now we're just going to solve each one like it's an equation. Divide by 5, cancel, and we get x is less than 7 over 5. Then over here, divide by 5, cancel, divide by 5, and we get x is greater than negative 7 over 5. Okay? And so now x can take on any value that is less than 7/5 or greater than negative 7/5. And there's a really neat way you can set up your answer. Put your smaller number first, so this negative 7/5, write that one first. Okay? And then see, because we're putting this over here, we're going to put the x over here. So we switch this around. If we switch this around, we got to switch this around. Okay, so now x is greater than negative 7/5, but x is also less than, see that? X is less than 7/5, and now we put x between negative 7/5 and 7/5. So as long as x takes on any value between negative 7/5 and positive 7/5, it'll satisfy this inequality. Let's try another one that has addition or subtraction instead of multiplication. And then we'll try one more that has maybe a fraction in it. So let's say that we have the absolute value of x minus 4 is, let's say it's greater than or equal to 9. Okay? All right, so we're going to do the same thing that we did before. Here's our rules. We're going to set the first one up without the absolute value symbols. So x minus 4 is greater than or equal to 9. We're going to set the second one up. We're still going to do the x minus 4, only we're going to flip the sign, and we're going to flip the inequality sign and then change the sign of the 9. And now we're going to solve. Over here, we're going to add 4 to both sides. Cancel, and we get x is greater than or equal to 13. Over here, we're going to add 4 to both sides, add 4 to both sides. That's going to cancel here. We're going to get x is less than or equal. Negative 9 plus 4 is negative 5. So here's the thing. This is a little weird. We cannot set this one up as one answer. Okay, because here's what it's saying. It's saying that x can be larger than 13 or equal to 13, or x can be less than negative 5 or equal to negative 5. What it's saying here is that x just can't be any number between negative 5 and 13. Okay, so as long as you can put any number in here, let's put in 100. 100 minus 4 is 96. Absolute value of 96 is greater than 9. Put negative 1,000. Negative 1,000 minus 4 is negative 1,004. The absolute value of negative 1,004 is 1,004, and that is also greater than or equal to 9. Okay, let's put negative 5 in. Negative 5 minus 4 is negative 9. Absolute value of negative 9 is 9, and 9 is equal to 9. So we're good. All right, let's do one more, maybe with a fraction in it. All right, let's see here. Let me look at my reference here. Oh, that could be good. All right, let's try 4x over 5 plus 1, let's say absolute value. And then let's put a minus 3 over here. And then let's say that this whole thing is less than or equal to 2. Okay? Well, here's another rule. You cannot mess with this absolute value thing until you have dealt with anything on the outside. You got to get rid of this stuff. You need to have the absolute value to be the only thing on the whole side of the inequality. So here's what we're going to do. We're going to add 3 here. We're going to add 3 here. That's going to cancel. And now we have the absolute value of 4x over 5 plus 1. That's gone. Less than or equal to 2 plus 3 is 5, right? All right, now before we mess with anything, we're not going to start multiplying and subtracting and stuff. First, we're going to set up our two separate equations. The first one you know the first one looks just like the problem without the absolute value symbols. So we got 4x over 5 plus 1 is less than or equal to 5. The other one looks the same, 4x over 5 plus 1, only we're going to switch the inequality sign and we're going to make this a negative, right? Over here, this is easy. We're going to subtract 1 from both sides, and we get 4x over 5 is less than or equal to 4. And then here, we can take 2 steps to do this or 1 step to do this. This is 4/5 times x. So we can cancel 4/5 with 5/4. Multiply by the reciprocal, and it cancels out the multiplier. Okay, so if we're multiplying by 5/4 here, multiply by 5/4 here. Here it's going to cancel the 4/5, and we're going to have x is less than or equal to 4 times 5 is 20. 20 divided by 4 is 5, or we just cancel the denominator, and our answer is 5. So x is less than or equal to 5. On this side, we're just going to follow the same procedure pretty much. We're going to subtract 1 from both sides, only this time 4x over 5 is greater than or equal to greater than or equal instead of less than or equal to, and instead of 4, it's going to be negative 6. Same thing, we're going to multiply by 5 over 4 to get rid of the 4/5. Multiply by 5 over 4. It's going to cancel these guys. That gives us x is greater than or equal to, negative times a positive is a negative, so we know our answer is going to be a negative. All right, 6 times 5 over 4, well 6 times 5, that's 30, so we got 30 over 4. 30 over 4, which can be reduced, okay? Each one of these numbers can be divided by 2, so really now it's x is greater than or equal to negative 15 over 2, and we're done. So now x can be less than or equal to 5 or greater than or equal to negative 15 over 2, and since the x less than this or greater than this is in between the 5 and this, we can write it as one answer. We can say negative 15 over 2, that x is greater than that, or greater than or equal to that, but less than or equal to 5. So this would be, we would write it as this final answer, as one answer. Okay? Well, I hope this helps. I hope it'll help you do your homework, and I hope it'll help you if maybe you're somewhere else in the world. I hope this helps you too. And have a great day, folks.